So let us recall what we discussed yesterday. So we started with the differential equation of simple harmonic motion. What is that differential equation? So differential equation is d2x by dt square is equal to minus of omega square x. Okay, or you can say d2x by dt square plus omega square x is equal to 0. Okay, and we know that omega square is equal to k upon m, where k is the spring constant if we consider spring block system and m is mass of the block. Okay, then we solved this equation and we found out that x is equal to, x is given by what? A multiplied by sine of omega t plus phi. X is given by a sine of omega t plus phi. Okay, so omega is called as the angular frequency. It is known as angular frequency of linear SHM. Okay, and then this term, this term is known as what? It is known as the phase. Okay, it is known as phase of the SHM. This is known as amplitude. Okay, so it is the distance from the mean position up to which that block can move. Okay, or you can say it is the maximum allowed displacement in SHM. Right. Then we saw two special cases for this. For a particle, or let's suppose for spring block system which starts from the positive extreme position. Okay, so for positive extreme position, positive extreme, we know that x is equal to a multiplied by sine of omega t, and for uh, the midpoint, okay, I mean, see, for a particle starting from positive extreme, okay, that's what I mean by positive extreme. Okay, so for particle starting from mean position, from mean position, x is given by what? It is given by, oh, I wrote it incorrectly. Okay, so for particle starting from extreme, positive extreme position, x is equal to a cos of omega t, and for a particle which is starting from the mean position, x is equal to what? A sine of omega t. Okay, so this is what we saw, right? And if you put t equals to 0, if you put t equals to 0, you get phi as phase, so it is known as the starting phase. Okay, it is known as the starting phase of SHM, right? Now we'll plot uh, the graphs for position, then acceleration and velocity in SHM. Okay, so let us see how do the graphs for the position, the velocity and acceleration in SHM look like. Okay, so let's graph the SHM. So yeah, we want to graph the SHM. Fine. So let's consider this case for a particle starting from positive extreme position. We know the equation for the displacement or position of particle, which is a cos of omega t. Let's find out expression for the velocity and acceleration. Okay, so let's find out velocity. So x is equal to a cos of omega t. What is velocity? It is dx by dt. So it is given by, if we take derivative of this, what do we get? Derivative of cos of omega t is minus of omega into sine of omega t. Okay, so minus of a omega multiplied by sine of omega t. This is velocity. And then what about acceleration? So acceleration, we know it is minus of omega square x. Okay, and by taking derivative of velocity we can find out that. Okay, so if you take derivative of velocity, what do you get? So dv by dt is acceleration. So it is minus of a omega square multiplied by cos of omega t. So derivative of sine omega t is omega multiplied by cos of omega t, right? This is equal to, we can say, if you take minus omega square out, then it is minus omega square multiplied by a cos of omega t. So a cos of omega t is x. Okay, so it is minus omega square multiplied by x, acceleration, right? Okay, so these are our equations. Now let us try to plot them. Okay, so I'm going to plot the displacement, the velocity and the acceleration on this vertical axis and time on the horizontal axis. Okay, all right. So what will be the maximum value of x? It is a, right? So the extreme values of x are plus a and minus a, right? So suppose this is plus a and this is minus a. Okay, then what are the extreme values for velocity? So it is plus a omega and minus a omega, right? Because value of sine is the maximum value of sine would be 1, right? So it is plus a omega plus a omega and minus a omega. This is velocity. And for acceleration, you have maximum value a omega square and the other extreme value is minus a omega square. Okay, so this is 0, 0 and 0. Okay, this is acceleration. Let me write it with different color. So this is acceleration, this is velocity and this is position. Okay, this is position. All right, so at t equals to 0, what is value of this thing at t equals to 0? So cos of 0 is 1, right? Cos 0 is 1. So x will be equal to plus a. Okay, x is equal to plus a. So this graph will start from here. Okay, then now let's consider t equals to, another point is t by 4. Okay, next point is t by 2 and next point is it will be 3t by 4. Okay, and the last point is t, small t equals to capital T. Okay, so what is omega t? Omega t is 2 pi multiplied by small t upon capital T. Okay, x is equal to a multiplied by cos of omega t, which is 2 pi multiplied by small t upon capital T. So omega is 2 pi upon t, right? So now let's substitute t equals to t by 4. So if you substitute that, okay, t by 4 here, then what do you get? So it is 2 pi multiplied by 2 pi upon t multiplied by t by 4. So what do you get? This t and t gets cancelled. It is 2 pi upon 4. What is 2 pi upon 4? It's pi by 2, right? So for t equals to t by 4, this angle will become what? Pi by 4. sorry, pi by 2. Okay, so what is cos of pi by 2? Pi by 2 is 90 degrees. Okay, so cos of 90 degrees is 0. So for t by 4, what will happen? It will go to 0. Okay, so you get this next point. Then you take t by 2. Okay, time is t by 2. Then what will happen? So if you take t equals to t by 2, then that angle will be equal to pi. Okay, so it is 2 pi upon capital T multiplied by t by 2, right? This is omega t. So this 2 and 2 gets cancelled. Okay, so t and t gets cancelled. So angle is pi. Here angle is pi by 2. Okay, then for t equals to small t equals to 3t by 4. How much would be this angle? It would be 3 pi by 2, right? And for small t equals to capital T, the angle will be equal to 2 pi. Okay, so now for t by 2, how much is the angle? It is pi, that is 180 degrees. What is cos of 180 degrees? Cos of 180 is minus 1, right? It's minus 1. So it is minus 1 multiplied by a. So you get minus a. Okay, so the object goes here. Then at 3t by 4, at 3t by 4, what will happen? Once again, it is sine of, it is cos of 270 degrees. Okay, cos of 270 degrees, it is also 0. So you get this point. Okay, then at t equals to capital T, the angle will be 2 pi. Cos of 2 pi is also what? 1. Okay, cos 0 is 1, cos of 360 is 1. Okay, cos of any multiple of 2 pi is 1. Okay, so you get this point. Then okay, this is for t. So if you join this graph, it will look like this. Now we have taken very few points, but the graph will look like this. Okay, the cosine curve looks like this. So velocity is given by sine curve t equals to 0. Sine 0 is 0, right? So velocity would be 0. Then at t by 4, okay, so this angle becomes 90 degrees, pi by 2. Okay, so sine of 90 is 1. So it is 1 multiplied by minus a omega. That is minus a omega. Okay, so graph will go like this here. This is the next point. Okay, this is t by 4. Next one is t by 2. Okay, next one is 3t by 4. Then sorry, 5t by 4. At t by 2, how much is the angle? How much is value of omega t? It's pi. Okay, sine pi is also 0. So you get this point. Then at 3t by 4, okay, it is plus 1. Okay, sine of 3t by 4, sorry, sine of omega t when omega t is 3 pi by 2 is equal to what? Minus 1 actually. That minus 1 multiplied by this minus a omega will give us plus 1. Okay, so this is the next point. And we can keep on plotting these points, so on and so forth, like this. Okay, so the graph will look like this. So this is a sine curve. Actually, if you uh, plot the sine curve, plot the mirror image of the sine curve, it will look like this. Similarly, we can plot acceleration. So for acceleration, now we don't have to do any hard work because acceleration is just minus of omega square x. So we have graph of x. So whatever is value of x, just put negative sign in front of that value and multiply it by omega square. Okay, then we get what? The value of acceleration. Okay, so at t equals to 0, x is a, therefore acceleration would be what? Minus of a multiplied by omega square. Okay, so this is the first point. Then at t by 4, x is 0, so a will be 0. At t by 2, x is minus a, so this will be plus a omega square. Okay, so on and so forth. We can plot these points and we'll get a graph like this. Okay. So this is how we plot the graphs for linear SHM. Okay, so this is a particular case, particle starting from positive extreme position. Similarly, we can plot the graphs for, sorry, similarly we can plot the graphs for particles starting from the mean position. Okay, that we are not going to do now. So let's talk about next thing, and that is SHM as projection of uniform circular motion. SHM as projection of uniform circular motion. Let's consider particle performing uniform circular motion. Okay, so let's consider particle performing uniform circular motion. Okay, so suppose this particle starts from this position and it moves along circumference of this circle. So suppose this particle starts from this position and it moves along the circumference of this circle in anti-clockwise sense. Okay, it moves in anti-clockwise sense. So in some time t, it moves from this position to this position. Suppose this position. So let's consider its position vector. Okay, so r bar is its position vector. Now you draw a perpendicular from position of particle to any diameter. Okay, it will meet at some point, and that point is known as the projection. It is known as the projection of this point. Okay, or this object. Okay, so you draw a perpendicular from position of particle to any diameter. Okay, x-axis, y-axis, then you can consider any diameter, this one, anyone. Then draw a perpendicular. So if I draw a perpendicular, it meets at this point, it meets at this point. So this point is known as the projection of this point. Okay, so now as this point will move on the circumference of the circle, what will happen to this projection? So this projection will move to and fro about this mean position, that is the center of the circle. Okay, so see, when this object was here, then its projection on this x-axis was also at the same point. When object moves here, projection is at this point. When object moves here, projection is here. When object moves here, the projection is here. Okay, when object moves here, projection will be here. So you can see that this projection is moving left and right, okay, about this mean position, and these are the extreme values. Okay, these are the extreme values up to which this projection can move. We can say this is minus a, this is plus a, and how much is the value of a? It is equal to radius of the circle. So when particle performs circular motion, its projection on any diameter performs what? Simple harmonic motion. It performs simple harmonic motion. Okay, so let's suppose this angle is theta. So if omega is angular velocity, omega is angular velocity of this particle, then theta will be equal to what? It will be equal to omega t, right? So projection is here. So this much distance is x, and if we consider projection on y-axis, then this much distance is y. So we can write r bar in terms of x and y. So r bar is equal to what? Or I can just say, yeah, r bar is equal to x into I cap plus y into j cap. And what are the values of x and y? So x is equal to r cos theta, okay, or you can say it is r multiplied by cos of omega t, because theta is omega t, and y is equal to r sin theta, that is r multiplied by sine of omega t. So you can see the equation of x is also SHM, equation for y is also equation of SHM. When particle moves along circumference of circle, its projection on any diameter performs what? It performs simple harmonic motion. Okay. Then let's consider one more thing, and that is, let's talk about addition of two SHM in same direction. So let's consider two SHMs. So x1 is suppose a or a1 multiplied by sine of omega t plus phi 1, and x2 is suppose a2 multiplied by sine of omega t plus phi 2. Okay, so for simplicity we'll consider the frequencies of these two SHM is same, amplitude is different, and phase is different. Starting phase is different. Okay, so there is phase difference. How much is phase difference? Phase difference is suppose phi, it's equal to phi 1 minus phi 2, because if you put t equals to 0, so this thing will be 0, this thing will be 0. Phase of first SHM is phi 1, phase of second SHM is phi 2, so phase difference is phi 1 minus phi 2. I want to add these two SHMs. Okay, so let's add. So resultant SHM, or we don't know whether it is SHM or not. Okay, so let's find out resultant displacement first. Okay, so resultant displacement due to these two SHMs which are happening in same direction. Okay, let's say x direction. So it is x will be equal to x1 plus x2, right? So let's put x1 equals to this, x2 equals to this. So it is a multiplied by sine of omega t plus phi 1 plus, sorry, it's a1, a2 multiplied by sine of omega t plus phi 2, and now we need to expand these brackets. Okay, so let's do that. So what do we get? We get a1 multiplied by sine omega t cos of phi 1 plus cos omega t sine of phi 1. This is expansion of first term. Then plus we have a2 multiplied by sine omega t cos of phi 2 plus cos omega t sine of phi 2. Okay, this is just expansion of sine of a plus b, sine a cos b plus cos a sine b, right? Then, so what we'll do is we'll take terms containing sine omega t and sine omega t common, and terms containing cos omega t and cos omega t common. Okay, I mean we'll group together the terms containing sine omega t and sine omega t and the terms containing cos omega t and cos of omega t. Okay, so if we take sine omega t common, what is left? So from this first term, it's a1 multiplied by cos of phi 1. Okay, it's a1 cos of phi 1. And what's there in second term? It's a2 cos of phi 2. Plus we have a2 cos of phi 2. Okay, then what about this? If you take cos omega t common, okay, so if you take cos omega t common, what's left? A1, it will be a1 sine phi 1 and a2 sine phi 2, right? So it's a1 sine phi 1 plus a2 sine of phi 2. Okay, then now what we'll do is we'll call this term as some resultant amplitude r multiplied by cos of delta, and we'll find out that resultant amplitude. And this one, suppose r sine delta. Okay, I will call this thing as, see, term which is in multiplication of sine of omega t. Okay, or you can say it's coefficient of sine of omega t. I will call it r cos of delta, and the coefficient of cos of omega t, I will call it r sine delta. Okay, so what do we get? We get sine of omega t multiplied by r cos delta plus, okay, cos of omega t multiplied by r sine delta. If you take r common, you take, sorry, r common, what do you get? It's sine omega t cos delta plus cos omega t sine delta. Okay, so then this can be written as, what? Sine of omega t plus delta. Okay, this can be written as sine of omega t plus delta, because it is sine omega t cos delta plus cos omega t sine delta, right? So it is r multiplied by sine of omega t plus delta. So now see, x is the resultant displacement, and it can be written as r multiplied by sine of omega t plus delta. Okay, so R is the resultant amplitude and delta is the resultant phase. Okay, so now if we are able to find out the equation for this resultant amplitude and resultant phase, then we can say that the composition of two SHMs which are in same direction is also an SHM. Okay, having amplitude equals to R, we'll see what that is, and the phase equal to delta. Okay, so now what is, okay, so I will just put a bracket over this. Then what is R cos delta? It's this thing. So it is A1 cos of phi 1 plus A2 cos of phi 2. And what is R sin delta? It is A1 sin phi 1 plus A2 sin phi 2. So let's call this equation 1 or 1 and 2. Okay. Finding delta is very simple. So just divide equation 2 by 1. So what do we get? R and R will get cancelled out. Sin delta upon cos delta is tan of delta. Okay. So equation 2 divided by equation 1 will give us what? Tan delta equals to this thing. Okay. This term A1 sin phi 1 plus A2 sin phi 2 divided by this thing. Okay. So A1 sin phi 1 plus A2 sin phi 2 divided by A1 cos of phi 1 plus A2 cos of phi 2. We get delta equals to tan inverse of this thing. A1 sin phi 1 plus A2 sin phi 2 divided by A1 cos of phi 1 plus A2 cos of phi 2. So we got delta. Okay, we got delta. So delta is the resultant phase. Okay, delta is the resultant phase. Then we want to find out the amplitude. So for that, these two equations are telling us actually that we have to square and add them. Why? Because if you square the left hand side, what do you get? R square cos square delta. And if you add R square sin square delta into it, what will happen? You can take R square common. It will be cos square delta plus sin square delta. That's 1. Okay. So let's square and add these two. So squaring and adding 1 and 2. What do we get? So it is R square cos square delta plus R square sin square delta. This is on left hand side, or you can say it is just R square. And on right hand side, let's square this. So square of this thing will be A1 square cos square phi 1 plus A2 square cos square phi 2 plus 2 times this thing into this thing, A1 cos phi 1 plus A2 cos phi 2. Okay, so it is A1 square cos square phi 1 plus A2 square cos square phi 2 plus 2 times A1 cos of phi 1, okay, multiplied by A2 cos phi 2 plus similarly square of this. Okay, square of this is A1 square sin square phi 1 plus A2 square sin square phi 2 plus 2 times A1 sin phi 1 multiplied by A2 sin of phi 2. Again, we can see here that if we add these, what will happen? You can take a1 square common. So cos square pi 1 plus sin square pi 1 will give us 1. We can take a2 square common. Cos square pi 2 plus sin square pi 2. Again, it gives us 1. Okay. And then this term is left. Let's see what happens with it. Okay. So we got r square equals to a1 square plus a2 square plus. Now here I can take 2 times a1 a2 common, okay, from these two terms. So if I take 2 times a1 a2 common, what's left there? Cos pi 1 cos pi 2 plus sin pi 1 sin pi 2. It is cos of a minus b, cos a cos b plus sin a sin b, right? Okay, so it is cos of pi 1 minus pi 2. Okay, so you get r square equals to a1 square plus a2 square plus 2 times a1 a2 multiplied by cos of pi 1 minus pi 2, and therefore r is equal to what? Square root of that. Okay, r is just square root of that. So we got this expression for r. Have we seen this kind of an expression anywhere? So that means the two SHM which are acting in same direction, okay, they add as if they are two vectors, as if they are two vectors. So what is resultant amplitude? Resultant amplitude is given by this formula of vectoric addition, square root of a1 square, that is amplitude of first SHM square, plus amplitude of second SHM square, plus 2 times amplitude of first one multiplied by amplitude of second one multiplied by cos of the angle between two. What's angle between two? Actually it is phase difference. Phase difference between two SHM. Yesterday we solved till this problem. Okay, let us see next one. A particle is executing SHM along a straight line. Its velocities at distances x1 and x2 from the mean position are v1 and v2 respectively. Its time period is. Particle is executing SHM along a straight line. Its velocities at distances x1 and x2 from mean position are v1 and v2 respectively. Its time period is. This is the question. So what should we do? We can write down expressions for velocities. What will be v1? It is omega multiplied by square root of, is their amplitude same? Yes, no? Yeah, it's same particle only. So it's omega multiplied by a square minus x1 square. Okay, v2 is omega multiplied by a square minus x2 square. Then what can we do? So we can square them. Okay, so squaring them will get v1 square multiplied by v2 square equals to omega square a square, omega square a square minus x1 square, not x1 square. There will be omega square in multiplication, and omega square a square minus omega square x2 square. Okay, now we want time period. And see, there is no a in any of these expressions. We can get rid of it. We just have to subtract these equations. Okay, subtracting, what do we get? v1 square minus v2 square equals to, so here this thing and this thing will get cancelled out. Then it is This will become minus of minus, so that's positive. Minus minus plus. Okay, and omega square x2 square minus omega square x1 square, or we can take omega square common. We want to find out the time period. This v1 square minus v2 square equals to omega square multiplied by x2 square minus x1 square. Okay, so let's take this on other side, or let's keep it. So it is, what is omega? Yeah, let's take this on other side. So what do we get? Omega square equals to v1 square minus v2 square upon x2 square minus x1 square, right? And then we can take square root of this. We can take square root of this. So we get omega. And what is omega? It is 2 pi upon t. So 2 pi upon t is this thing. Okay. So 2 pi upon t is this thing. So let's take reciprocal of it. So we get t upon 2 pi equals to x2 square minus x1 square divided by v1 square minus v2 square. And now we can move that 2 pi on other side because we want period. Sorry. Okay. So this is the answer. So option D is the answer. The radius of a circle, the period of revolution, initial position, and sense of revolution are indicated in figure. Y projection of the radius vector of rotating particle P is. See this particle, it is at this position at t equals to 0. It's given. It is moving in clockwise sense. Okay, it's moving in clockwise sense. Okay, so how to think about it? See, after some time t, what will happen? It will go somewhere. Let's suppose it goes here. Okay, it's moving like this in in clockwise sense. So this much angle will be omega t. What will be omega? Omega is equal to 2 pi upon capital T. So omega t we want, it is 2 pi upon t, which is 2 pi upon, it's 4 seconds, 2 pi by 4 multiplied by t, or you can say it's pi by 2 times t. Okay, now it's clear actually. It's option A, right? Very good. Okay, because amplitude will be equal to what? Radius of circle, which is equal to 3 meters. 3 meters. Okay, so because it's moving like this angle is omega t. So if you draw a perpendicular from here, you get y projection. Okay, so that will be r multiplied by cos of omega t, right? Because it is through this angle, cos of omega t. Okay, so cos is there in this one, this one, this one, but uh, the phase is right in this one only. Okay, and that's why it's option A. Let's see next question. This you have to tell me. This is fairly recent, NEET 2020. Phase difference between the displacement and acceleration of a particle in a simple harmonic motion is pi, 3 pi by 2, pi by 2, 0. Okay. So Preeti told, is it correct? We just saw this, right? Phase difference between displacement and velocity is pi by 2. Velocity in acceleration is pi by 2. So displacement and acceleration, it is pi. Next question. The oscillation of a body on a smooth horizontal surface is represented by equation x is equal to a cos of omega t, where x is the displacement at time t and omega is frequency of oscillation. Which one of the following graphs shows correctly the variation of a with t? Acceleration with t. Tell me. See, x is a cos of omega t. So what will be a? It is a omega square minus of a omega square cos of omega t. So at t equals to 0, okay, this thing will be 1. So a is minus a omega square. It starts from negative value. Right? Yeah, it's option C. The particle of mass m oscillates along x-axis according to the equation x equals to a sine omega t. The nature of the graph between the momentum and displacement. We want the graph between momentum and displacement. That is, on y-axis we'll plot momentum, on x-axis we'll plot displacement. Okay, so x is a sine omega t, right? What will be velocity? It is equal to a omega multiplied by cos of omega t. Okay, and you want momentum. Momentum is mass into velocity, so it is ma omega cos of omega t. Okay, so then now if this was a only, that is if m and omega is equal to 1 and 1, then it could be a circle, right? Okay, this is, we are going to plot this on y-axis. Okay, so see, if you square and add x and y, what do you get? X square plus y square is equal to, okay, a square sine square omega t plus m square a square omega square cos square omega t. So if m and omega is equal to 1, you can take a square common, okay, then it will be sine square omega t multiplied by, sorry, plus cos square omega t, that's 1. So if m square and omega square or m and omega is 1, then it would be a circle, because this is equation of a circle. Okay, but right now it's not the case. So what will be the answer? X square plus y square, okay, is this thing. Now see, if I divide y square, if I divide y square by m square omega square, okay, m square omega square, and then if I add them, so x square plus y square upon m square omega square, what do I get? I will get a square, it is sine square omega t plus a square cos square omega t, right? So what I have done is, now I am not adding x square and y square, I am adding x square and y square upon m square omega square. I will explain. Okay, why? So this thing, if you add, what do you get? You will get a square on right hand side. Now can you tell me, this is an equation of something? Or if you take that a square also on left hand side, okay, what do you get? X square upon a square plus y square upon a square m square omega square is equal to 1. So This is an equation of ellipse. Okay, equation of ellipse, it's x square upon right. Okay, x square by a square plus y square by b square is equal to 1. Or you can say x square upon a, sum a plus y square upon b is equal to 1. Okay, this is an equation of ellipse, right? So the answer is ellipse. Okay, now let's see how does that ellipse look like. Okay, so at okay, on x-axis we are going to plot a sine omega t. So at t equals to 0, at x equal to 0, that means at t equals to 0, what will be the value of this one? Okay, when x is 0, it is either plus a omega, sorry, plus ma omega or minus ma omega. Okay, what will this mean? Where at mean position, particle can be moving like this or like this. Okay, the magnitude of velocity will be same, right? So when x is 0, the momentum is ma omega or minus ma omega. Then when x is at the extreme position, okay, so when x is plus or minus a, then what will happen? So at that position, at the extreme position, we know the velocity is 0. So at plus a and minus a, the momentum will be 0, right? So ellipse will look like this. So it will look like this. So now it depends on values of m and omega. Okay, if m and omega is equal to 1 and 1, then what will happen? So this thing becomes a and this thing becomes minus a. So then it will be a circle. If m and omega, m times omega is less than 1, then you will see ellipse like this, which is okay elongated on x-axis, right? Because then this value will be smaller than this value. Okay, this length will be smaller than this length. And if m multiplied by omega is greater than 1, then this length will be more, right? Then you will see ellipse like this. Okay, ellipse like this. Is it clear? So let's see next question. Two simple harmonic motions of angular frequency 100 and 1000 radians per second have the same displacement amplitude. The ratio of their maximum acceleration is. So this is very simple. Okay, amplitude is same, but the angular frequency is, for first one it's 100, for second one it's 1000. Sorry. So what's the answer? Maximum acceleration. So a1 max divided by a2 max. We can say it is omega 1 square a divided by omega 2 square a. A is same, so this thing will get cancelled. Okay, so it is 100 divided by 1000 square. What's that? 1 upon 100, right? Option D. A point performs simple harmonic oscillation of period t, and the equation of motion is given by x equals to a sine of omega t plus pi by 6. After the elapse of what fraction of time period, the velocity of the point will be equal to half of its maximum velocity. This is a simple question. We have solved similar question yesterday. Okay, let's solve this question and stop. Okay, so x is equal to, we have x equals to a sine of omega t plus pi by 6. So velocity will be what? Derivative of that, that is a omega multiplied by cos of omega t plus pi by 6. Okay, and we want the time at which the velocity becomes half of the maximum value. So maximum value is a omega, so velocity is half of that. Okay, so a omega and a omega gets cancelled, so we get half equals to cos of this thing, omega t plus pi by 6. So how much should be this angle? So cos of which angle is half? It's 60 degrees, right? 60 means pi by 3. Okay, so omega t plus pi by 6 is equal to pi by 3. That means omega t, what is omega t? 2 pi small t upon capital T is equal to pi by 3 minus pi by 6. That's pi by 6. Okay, so pi and pi gets cancelled out. So what do we get? T equals to, it is capital T divided by 12. Okay, option B is the answer.